As most of you know, a lot of soils in Oklahoma are hard red clay and a little bit difficult to deal with. But they may not be 100% clay. And we've got some ways of determining what percentage is in there and how to make it better for growing your crops. First of all, most soils in the garden, such as this nice sandy soil I have here, are not all soil. As you can see from this pie chart, 25% of the soil, of good soil that is made up of air. 25% of it is made up of water to help move nutrients to the root system. 5% of it should be made up of organic matter. This will help improve your soil tilth and help maintain a good balance of microorganisms in the soil to help make it more productive. The remaining 45% is what we call the mineral portion. This is the part you're most familiar with. Your soil can either be a sandy soil, such as this one. This is from down in Perkins, south of Stillwater, and they're blessed with a nice sandy soil that feels gritty to the touch. It was just dug a few days ago, and as wet as our soils have been, you can see that this is just nice and crumbly. One problem with the sandy soil is that even though it's very porous and it drains very well, it's not able to hold on to nutrients very well because the nutrients such as nitrogen and phosphorus and all have an electrical charge, and they need to be bound to the individual particles. Sandy soil doesn't do a very good job of this. And so in that type of soil, you might want to add some more organic matter to help hold some of those nutrients in the soil and also to help hold moisture. Now, another type of soil is this soil, and it came out of our garden, our studio garden here in Stillwater. It looks rather sticky to the touch, but we found out it's actually a silt type soil. A silt soil is sort of like a sandy one, but the particles are much, much finer, and they generally contain more nutrients than a sandy soil. And it does stay a little bit sticky, but it will dry out more quickly than a clay soil and doesn't feel quite so greasy to the touch. A heavy clay soil, as you know, is a very fine line between being too sticky and too much of a gumbo to work in, and then turning very dry and hard and cloddy. Many parts of Oklahoma have clay soils, and they're hard to deal with in the garden. One way you can improve any of these three types of soils is to add organic matter. This is some compost I brought from my bin at home, and we've just been building it up over the past few months with adding ground up leaves, a little bit of manure, grass clippings, and what have you. And this is going to give a nice amount of material to add to our garden to improve the soil. And one thing I like to tell people is that you can't add too much organic matter to the soil. You could grow something in straight cow manure, and of course that'd be too harsh an environment for the plants. But if you use compost, in an average garden that's, say, 20 by 20, if you put in, say, a pickup truck load, that would still not be too much. It will really help the tilth of a sandy soil, a silt, or a clay. Now, to determine what kind of soil you have in your garden, Jim has a very unique method that's quick and easy to give you a very clear picture of what kind of soil you have.
As Sue is saying, what type of soil you have will determine to a greater or lesser extent what management practices you need to do to get your garden soil into the best shape that it can be. You can tell a lot about what type of soil there is just by feeling it, just by rubbing it between your fingers. If you're good at it and practiced at it, you can tell very closely what type of soil it is, even down to being a sandy loam versus a loamy sand. There are a few of us, myself included, who haven't really perfected that technique and need some more objective method of telling what's in the soil. And we're going to show you a method today that you can do very easily in your home that gives you reasonably accurate results on what your soil type is. This method depends upon the fact that the three main components of soil, the mineral parts, sand, silt, and clay, are all different sizes and have different densities and will sink out of suspension at different rates. The sand particles, being larger and heavier, fall out very quickly. The silt particles are smaller. They fall out fairly quickly, but do so over a matter of several hours rather than seconds, as the sand particles do. The clay particles are the smallest. They will take many, many hours to fall out. So by taking and making a soil suspension, shaking it up well, and then timing and marking at different levels where the level is, you can tell how much of your soil is sand, silt, and clay. And from there, I'll show you how to take that and find out what exactly kind of soil you have. First step, find yourself a glass jar, a quart glass jar, a canning jar or a mayonnaise jar. Either will do just fine. Fill it up 2/3 full of water. And then add about 1 teaspoon of some sort of surfactant. A wetting agent for spray materials works fine, or just liquid dishwashing soap works just as well. This will help break up the soil particles as you're mixing them so that you can get the separation, so that the clay particles will separate apart and act like small clay particles instead of larger silt. Now add some soil. The actual amount is not critical. You don't want to fill the jar completely full because you need room in there to be shaking this back and forth to get good mixing action. So you have water, a little bit of surfactant, and your soil. The next step is to get this mixed up thoroughly. Now, in a soil lab, they will put this mixture in a blender and mix it around. I don't suggest you do that with your blender. It could ruin your relationship with your household cook. But you do need, I want to stress that you do need to get this mixed up thoroughly. So you're going to have to shake it for several minutes. It's a good idea, especially if you have a heavier soil, a silty or a clayey soil, to let it sit for 15 or more minutes and let the soil get soaked up in the water. You probably may need on these heavier soils to actually break up some of the soil clods and get it mixed up. Use a wooden spoon or a large piece of wood, something like that, to get it mixed up thoroughly. It's important to get good results, to get that soil thoroughly dispersed in the water. The soil I'm using here is a sandy loam. I know that from before. It shows it because it has a good amount of sand so that we can get a good demonstration of the first technique. Get it mixed up thoroughly. Have a watch handy. Set it where you can see it. Set it down on a table or other flat surface and time 40 seconds. Within 40 seconds, all of the larger sand particles will have settled. And you're going to have to look close because there probably won't be a color difference between the sand and the still suspended part. But if you look carefully, you'll be able to see where the mark is between what has settled out and is no longer moving and the suspension part, where you'll still be able to see some movement of the particles as they're still either settling down or swirling around in the water solution. And then when 40 seconds comes, make a mark. After that, leave the jar in the same spot and leave it undisturbed for another 2.5 hours. Within that 2.5 hour period, all of the silt particles, which are the intermediate size, will have settled down. At the 2.5 hours, make a mark where the silt is. Then let it sit for 24 hours. During that 24 hours, the very small particles, the clay particles, will settle out. Then you can mark the clay portion. Some of the very small clay particles will probably never settle out, no matter how long you leave it. They're just so small, they'll stay in suspension indefinitely. Just after 24 hours, you've got most of it, and that's as accurate as you need for analysis such as this. Over here in this jar is the same soil. We've made the mark for the sand, and it's been sitting for 24 hours, and we've made the mark for the silt. As it turns out, this soil has very little or no clay. There was basically no additional sediment after the silt had settled out. What you'll do is then measure using a ruler or some other way of measuring the thickness of the 3 layers, and then figure that out as a percentage of each of the 3 constituents, the sand, silt, and clay. This particular soil was 65% sand, 35% silt. Knowing that information, you go to this soil triangle, which looks terribly complicated. If you go through it carefully, it isn't as hard to read as it looks like it is. You read the percent clay on this side, it goes from 0 to 100. The percent silt on this side, 0 to 100. And sand is along the bottom from 0 to 100%. If you notice the arrow on the end, it points in a direction. That's the direction that you read. Okay, we'll start down on sand. It's 65% sand. The little arrow points up this direction. So we'll draw an imaginary line at 65 through here. We had 35% silt. You notice the arrow for silt points down this direction. We'll draw an imaginary line down here to where it intersects or joins the 65% sand line. And this is down in the area that's designated as a sandy loam soil. So we now know that this soil is a sandy loam. This sheet and the directions for doing this test are available. We'll tell you where to send for the directions later on in the show. It also gives a few sample problems, samples and examples of how to work this chart, so along with careful directions. So you should be able to find what type of soil you have by figuring out what your percentage of those 3 components are, and then referring to this chart.